Hi guys, my name is Vlada, and in this video we will continue the problem from the previous video, integration over the triangle. So we divided the triangle in three straight lines. First was AB, second was BC, and the third was AC. So we did integration over this straight line AB, and in this video we will do integration over this line BC and over line AC. The final solution will be the sum of these three integrals. I just want to remind you that you could even do the integration from the point C to point B or here, and you could do integration from the point C to point A. You will get the same result because integration doesn't depend on the way you are going. Okay, so let's calculate first this integral over the straight line BC of scalar field x plus 3y times ds. Okay, let's parameterize our curve. That will be the first step. We have point B with coordinates 1, 0, and that will be our first point. And we have point C with coordinates 1, 1, and that will be our second point, actually our last point here, finishing point. So we need an equation of straight line from B to C. X minus x1 over x2 minus x1 is equal to y minus y1 over y2 minus y1 is equal to t. So let's plug in these values. Actually, I will write here that x1 is equal to 1, x2 is equal to 1 also, y1 is equal to 0, and y2 is equal to 1. So this will be my values to plug in here. X minus 1 over 1 minus 1 is equal to y minus 0 over 1 minus 0, and that is equal to t. From this we get that x minus 1 over 0 is equal to t, which means that x minus 1 is equal to 0 times t. So x minus 1 is equal to 0, or x is equal to 1. So we are parameterized x. Okay, now let's do the parameterization of y. Y over 1 is equal to t. Oh, that was easy. Y is equal to t. Okay, and t goes from 0 to 1. I should write that here, but whatever. That was our first step. Yes? Yes. Okay. Yeah. Sorry. That was our parameterization. Let's do the second step. We will calculate line element. sorry about that. We'll calculate a line element derivative of x squared plus derivative of y squared times dt. Okay, derivative of x is equal to derivative of 1 actually, and that is 0. Derivative of y is equal to derivative of t, and that is equal to 1. So we have 0 squared plus 1 squared times dt, which is equal to dt. So ds is equal to dt. That was the second step. And third step will be to plug in everything that we have. Integral over ab of x plus 3y times ds is equal to ordinary integral with boundaries 0 and 1. 0 and 1, x is equal to 1 and y is equal to t times ds is equal to dt. So we have integral from 0 to 1 dt plus integral from 0 to 1 3t, dt, which is equal to 1 plus 3 halves using Newton-Leibniz formula. So we've got how many? 5 halves. This is the result of the second integral. 5 halves. And finally, let's do the third one. Integral, I will do that here. I think this is enough space for doing that. Integral over the straight line AC of x plus 3y times dc, where a is 0, 0 and b is is 1, 1. Okay. From here, actually a is x1, y1 and c is x2, y2. So x1 is equal to 0, x2 is equal to 1, y1 is equal to 0 and y2 is equal to 1. The equation of the straight line from A to B is x minus x1 is 0 over x2 minus x1, that is equal to y minus y1 is 0 and y2 is equal to 1 minus y1 is equal to 0, that is equal to t, where t goes from 0 to 1. So we get that x over 1 is equal to t, or x is equal to t, and y is equal to t also. That was our parameterization of AC. Oh God, I don't have enough space. Sorry about that. Let's expand our canvas. 9,000. It will be pretty large canvas. I hope that I will finish my problem. I hope that application won't do some problems. Won't make some problems. Okay, let's calculate ds. ds is equal to square root of x derivative x squared plus derivative of y squared times dt. Okay, derivative of x is equal to derivative of t, which is equal to 1, and derivative of y is also derivative of t, which is equal to 1. So we have square root of 1 squared plus 1 squared times dt, and that is equal to square root of 2 times dt. That is our line element ds. Okay, let's finalize our problem. I don't have any room to write anymore, so I will write here that this was our second step for this integral. Okay, this was our integral, and this was the first step. I will frame the first step with this green line. Okay, this was our problem, and this in green line is our parameterization of the straight line, curve, whatever. This was our second step, and let's do the third step. Third step is just to plug in everything, and I will do that here. This was pretty tough. Integral from a to c of x plus 3y times dc is equal to ordinary integral from 0 to 1. T goes from 0 to 1. Okay, from 0 to 1, ordinary integral. X is equal to t plus y is equal to t also from here. So we have 3 plus 3 times t, and ds is equal to square root of 2 times dt. Square root of 2 times dt. So we have 4t times square root of 2. So we have 4 times square root of 2 in front of our integral, and here we have t times dt, which is equal to, using Newton-Leibniz formula, 4 square root of 2 over 2, which is equal to 2 times square root of 2. So this is the third integral. Two times square root of 2. So finally our solution, this integral, is equal to 5 halves plus 1 half is equal to 6 halves, and that is equal to 3 plus, and this is equal to this number. So that was that from this video. See ya in next video. Bye bye.